Okay, so today we will see sway frames. Otherwise, you can take translational. So, translational contributions. Okay, so suppose a frame is there. If it is so translational, are understood? Same delta. The frame is translational or not bending. It's moving one direction. It's give displacement, not a rotational displacement. Translational displacements. You already know if the movement is moving in one side, giving the translate displacement, extra moments will develop. You already know it. Okay, extra moments. What is that? Extra moments. If it is fixed, if it is fixed, what will happen? The support, if support, translational support, if it is there, how it is, how much it is, 6ca by delta L square, 6ca by delta L square. And also if it is hinge joint, how it is 3ea by delta L square. You already know it. It's a translational displacement. Are understood? So how to do, or how we consider into the Kani's method, today's topic. See, first we have to take care. First I will show one thing. Previously we solved the same problem, like MAB. How we write it? The final end moment, how we write it? Fixed end moment plus rotational contribution at the end of the B, and the rotational contribution from the far end. That's it. That's it we write. And also we have to add translational contribution. Understood? So this is a fixed end moment. This is a rotational contribution at that joint. This is rotational contribution from the far end. Now we have to add, so I will add double. Add rotational, not a rotational, it's a translational moment developed at that joint. That's it. Translational moment added at that joint. That's it. This is a translation. That is the equation. That's the equation. So by this, what you done? So previously I think you already remembered A, B and AC, you write it. So same thing, you can write it same. Otherwise M AC plus 2M AC CA plus double dash AC. So you just sum it up. That's it. You just sum it up. You will get this is value equal to 0, because at the joint, any joint, the total moment is 0. Equilibrium equation is equal to what? You get sum of the AP to sum of the AC, sum of the PA, but sum of the translation. So finally you write this equation, sum AB is equal to what? You write minus 1 by 2 sum of the fixed end moments, sum of the rotational contribution from the far ends. Now the sum of the translational contribution also. So later, just by the stiffness, you write MAB is minus 1 by 2 K by sigma K MAP plus MBA AB. Same, this is RF. You already know everything, you know. Just added it, this a translational rotation, translational contribution at the joint. At the joint, are understood? This is a fixed end movements at the joint. This is a rotational contribution from far ends of the joint. This is a ABACAD, like this na, ABACAD. So translational contribution from the that end. Okay, so I will show later in problem what is that value. So just this is added. So now what? Now my intention is we have to calculate this value. How this we have to find out? This is a sum of the, see, this is the sum of the translational contribution at the joint. We have to find out the individual. So how? This is the first. This is you take as a first thing. Second we will find out. So how we have to find out? See, now it's the second proof. Suppose you take a single bay. It has a translational displacement, not a beams. You don't feel that sway. In a continuous beams you don't expect a sway. Only frames you will expect a sway. Okay, so see, I take it, this is a P, Q, R and S. If the sway is happened, what is that means? A shear is there in this frame. That's it, a shear. What is that shear? Maybe H. So sway, translational moment is there means what? So compulsory you expected some shear is there. That's it. So for that you will expect this is H1, maybe this is H2. I will take, see, for this whole proof you will consider the length of the two columns is same. So for if different, for the different we will discuss later classes. Okay, see, the length of the columns are same, you expect it. So otherwise sir, only single bay is sufficient, only single bay frames are you are doing. No, if you want add it, if you want add another bay also. If you take any frame like this na, so any frame, not only single frame, so many stories buildings are there. So don't expect only single bay. This proof is sufficient for any number of stories and any number of frames. Okay, so like this. So maybe if it is total shear is H in the story total shear is H. So the reactions are H1, H2, H3, maybe it's PQ, RS, T something. You maybe you take it, just feel it. First I will take only one column. I will draw free body diagram. What I will draw? Free body diagram. So it has C. This is H1. This is also H1. That's it. In the free body diagram, it has only H1 shear. In this H1, in this H2, in this H3. Total story shear is H. Are understood? So divide. So see, the final end moment, not a fixed end moments. The final end moment at P is something MPQ. Final moment, I write small letters. Final moment at QP. MQP. Final moment. So this is the free body diagram. We already drawn so many free body diagrams previously. Final moments, shear, and also if you want vertical reaction also, this is the vertical reactions. Okay, this is a free body diagram. So for the free body diagram, should be is in equilibrium. Should be is in equilibrium. So write down the equilibrium equation. So how can you write this length is L? Okay, MPQ plus MQP plus H1 multiply with length. So length, that's it. So don't call it as length, you can call it as a height. So column height, not its beam length, column height. So we have to mention it is in HR, story height. Okay, story height. So same thing I will write height of the column, not length. Length is not a good word to represent a height of the column. Okay, height of column. So okay, HR should be equal to 0 na? Should be equal to 0 because it's equilibrium equation. It's an equilibrium equation. Okay, so by this you can write what you can write. H1 is what you can write, MPQ MQP divided by HR. by this you can write down H2 also. For this H2 RS column also you can write it na? H2, how can you write it? Same, RS small letters you can write SR divided by HR. By this you can write it. So if you add both, if you add everything, what you will get? H story shear, H1 plus H2 plus H3 story shear is equal to the, you can write summation of MPQ summation of MQP. What is the summation means? The summation means PQ RS TU, that's it na? From bottom PQ RS TU. This summation means QP SR UT. Rotational contributions, see, not a rotational contribution, these are the final end moments. Understood? Final end moments, that's it na? That's it. So this is, you can, sorry, divide by HR. Okay, that's the one. These are the final end moments. Okay, you can MPQ means what? MPQ MRS MTU. Sigma QP means MQP MSR MUT. Okay, otherwise this is the first equation. Later I will write it. So if you see, previously I write like, what is a final end moment of PQ? What is a final end moment of PQ? A fixed end moment of PQ, 2 of rotation contribution at PQ, 2 of the rotational contribution at the joint of P, in the direction of the Q, plus rotational contribution from the Q towards P. Rotational contribution at the Q towards P. We already write it. That's it, na? We already write it. Previously we write it. Same thing. AB. The same thing I am writing. And plus and translational contribution. I will write 2 dips. Translational contribution. Double dash. I already know. You know it. Again I will write QP. Final moment. Fixed end moment QP. So rotational contribution at the Q joint towards P, rotational contribution at the P towards Q, plus this translational contribution QP, translational contribution at Q towards P, understood? So now one thing you have to observe it. If anything, just like if it is a frame, if it is a frame, if it is a frame, so the translational contributions, just think it is translational contribution, think it is like, if it is p, it is a q. What is that value? That value is, this value is what? 6ca by delta L square. This value is what? 6ca delta by L square. The same thing, na? Same thing. So these two are equal. These two are equal. PQ and QP are equal because one end is displaced from its position in the direction translational displacement is happened. The fixed end moment generated is same at the two ends. That's one thing. That one thing is m dash pq is m double dash qp. One thing is right. And the second thing, I am taking this liberty see, these two fixed end moments pq and qp. Sir, what is that values? If any load is on there, they have. But see, most of the columns in a frame, they experienced only wind loads. Na? So not this type of direction, this type of loading is not acting anywhere. Mostly acting a wind load, like uniformly distributed load. Understood? Otherwise no load. If anything load is there, only type of wind load, not an eccentric loading. Most probably not place. So if any eccentric loading on the column, this method is not suitable. I said once again, if any eccentric loading, it's not suitable. Any type of wind load, otherwise the load symmetry is not symmetry. Already sway will happening. So sway will happen, we can take care it. If the load is there, that is a wind load. Otherwise no load. Then only the method is suitable. Okay. See now. MPQ and MQP. Okay. Just see it. Add both. So these three, just delete these two. I will explain. Just add it. These two. See, 3m dash pq, 3m dash qp. These are two equal. 2mp pq. That's it, na sir. What is these two? I said most of the cases these two are zero. Sir, if wind load is acting, what? If the wind load is acting, what is these two values? One thing is WL square by 2, another thing is W minus WL square by 2. If they add both, should be 0. If add those two, both should be 0 because one is positive, one is negative. I said if any eccentric loading is acting, then only these two are different. If it is not eccentric, those two should be equal in opposite direction. So if you add both, it will be 0. Okay, are understood? So that's the thing. If any eccentric load is acting, this method is not suitable. That's it. On the column, not a beam. On the column, if any eccentric load is acting, we can't do nothing. Okay, that's the thing. That's the thing, na? That's the thing. Okay, you understand. Now you can see. For the PQ, QP, we write it. For the PQ, QP. So for the PQ column. Next RS column. For the RS column, what will happen? M small rs and SR. What will happen? Same 3 rs 3 SR 2 double dash rs. So how many columns are there in the story? Just add it. Sum of the PQ, sum of the QP is equal to the 3 PQ rotational contribution, 3 sum QP, 2 sum translational contribution. Okay, translational contribution. That's it, na? 3 3 3. Just this means what? PQ, RS, TU, everything. Okay, now this value, just separate this value, separate this value. What will happen? Sum of the total translational moment is equal to the, what will happen? What will get? What you will get? This 3, this is just 1. Just think it is 1 by 2, 1 by 2 PQ QP. This is going to be that side, so minus 3 by 2 sum of MPQ sum of QP. That's thing, na? That's thing. That's the exact thing. That's the exact thing. So this is the value. This is the value. Now we can see what is this value. Sum of the final end moments PQ QP. So we just derived where it is here. Here we derived. See, PQ and QP. What is that value? H multiply with this value. H multiply with story height and minus. Understood? From 1 you will write what you can write, minus, okay, HR divided by 2 minus 3 by 2, same thing, sum of QP. Okay, sum of PQ and QP. Now you can see. I will write 3 by 2 outside. 3 by 2 outside. What will happen? HR divided by 3. That's it, na? Minus, no, it's a plus. Sum of PQ, sum of QP. Rotational contribution at P towards Q. Rotational contribution at Q towards P. Okay, understood? So that value is PQ. This is the sum, sir. This is the sum of the translational moments. Sum of the translational contributions. PQ, RS, TU. This is the sum, na? So we want to find out the individual. As usual, previously calculated stiffness by divided by total stiffness. The same thing. Here also you can observe it. Sir, how can you observe it, sir? So just think it is a translational contribution. What will happen? What is that value? Just think it is here. It's a 6EA by, na? 6EA delta by L square. So something 6EI delta by L square. If you just think it, observe it. It has 1.54 EI L delta. You can write it. Just split it. What is this value? This is a stiffness. So inside, based on the stiffness only, it will generate it. Are understood? Based on the stiffness only, it generated 6EI by L square. Stiffness means it has L. In the stiffness, it has a flexural rigidity and L. Based on the stiffness only, the value is dependent, na? So based on that, MPQ. So maybe you can write M RS. RS also you can write 1 by 5 L is a K. It has a K1 or KPQ. It has a KRS delta. You can write it. So if you want to sum it, what you will get? Sum you will get. This value is minus. Okay, it's a minus 6.8. Okay, minus 1.5 L. Sum of the stiffnesses delta, because sir delta doesn't change because in a story, if any story its delta is same. Okay, for a particular story the delta is same. It will go like this. Particular story delta is same. So previously I developed this now. So that by this you can just see these two, one divided by another. PQ is what? Minus 1.5 L K of PQ delta. Sum of the PQ is L sum of the stiffness delta. So previously what I write, same thing. MPQ is what? PQ K delta delta also cancel. K divided by delta K. This is already we written in first day. So by this see here already we have this equation is there. By this you can write M double dash PQ, the translational contribution at P towards Q. How can I write? See, we have already 3 by 2 minus 3 by 2 K divided by sum of the K. What is this value? HR by 3 plus rotational contribution MPQ plus MQP. Sum. This is our important value. Okay, that's the thing. Fine. Sir, what is this value? Previously it has minus 1 by 2 K divided by sum of the K, stiffness divided by sum of the. Now it is a 3 by 2. This is a displacement factor. You can call it as a displacement factor. You can call it as a displacement factor. So what is this HR? So H multiply with HR you can call at a story moment. H means total shear, multiply with height. You can call story moment. Okay, so what is this, sir? What is these things? See, you can observe it. These are the rotational contribution at the top and bottom. PQQP means what? At the top and bottom. Rotational contributions. If you see, it's also sum. It's also a sum of the top and bottom of the total stories. If you see, if it is there, this is PQ RS TU, the sum of the rotational contributions total. Sum of the rotational contribution at P and R, sum of the rotational contribution at S to R, R to S, U to T, T to E. These are the rotational contributions, not at one joint. Previously, for the previous equations, we calculate say sum of the fixed end moments plus rotational contribution at particular joint. So particular joint meant RS and RP. Like. But for the translational contribution, these rotational contributions are just included here. What are those rotational contributions are? Is at top and bottom. Okay, top R and P, S and P. That's the end. That's the equation we developed. Okay, so now we can do the procedure. Now we can do the problem. Okay, this is somewhat easy derivation, but I don't want you to do the derivation. No, I don't want you to do. But how we can develop, you just observe it. What are the modifications we took? What are the obligations? This is one obligation, and one another obligation is height of the columns are same. Those are the obligations we took it. Okay, so by this we calculated this equation. Okay, so now I will do one problem. Today I will do one problem. Tomorrow I will solve another problem also. Okay, so So come on, start the problem. Start the problem. I will do one problem today, because once I solve the equations, once I did the derivation, you can't understand what is these values, what are those things. But okay, I explained very slowly. Okay, why it is. Okay, for the doing, if you do the one problem, you can understand. So very simple problem, not a simple. Okay. So I will do one problem. 50 kilonewtons. Storage shear is 50 kilonewtons. Okay, and a uniformly distributed load is 20 kilonewton per meter. You can directly say that it has a sway. If it is 50 kilonewtons is not present here, it is exactly symmetrical, there is no sway. You can do that problem very easily. Okay, so it has a sway, it is tilting towards our right side. Okay, so we have to find out the translational contribution also, we have to include. So how can you do, sir? So I will say first it's a 2i, it's a 3 meters, it's a 6 meters. I can assign this is a b c d. Okay, a b c d. So now first I want to do fixed end moments, just fixed end moments. MAB, MBA 0, same MCD, MDC. MBC is what? WL square by 12. What is that value? Minus 60. MCB is plus 60 kilonewton meters. You already know it. So now later distribution factors, that to the rotational contribution factors, that to the displacement factors. Rotational factor, displacement factor, and distribution factor, these three different factors. So take the giant B is there, na? Giant B is there. BA is what? 4A by length is 3. BC 4E, it has a 2i. Are understood? It's a 2i divided by 6. So what you will get? Same thing you will get, na? You will get same thing, 4a by 3, 4a by 3. So that's it, what? 8a by 3. So 1 by 2, 1 by 2. These are the distribution factors. So rotation factors is minus of distribution factor. You already know what is it? Minus 1 by 4, minus 1 by 4. C, giant C, CB, CA, CD. You will get same thing. No need to calculate it. CBCD, same thing, na? Same thing. 4E 2y by 6, 4a by 3, same thing, same thing, same thing. Okay, same thing. Same thing. So and also you have to find out the distribution factors. See, not a distribution factor, rotation factor is over. You have to find out the displacement factor also. Displacement factor is also same, but stiffness, that is a distribution factor multiply with displacement factor is equal to the minus 3 by 2 multiply with distribution factor. That's it, na? Distribution factor. Are understood? That's it, na? So same thing, same giants. You can find distribution, see, displacement factors. Sir, what is the displacement factor? Displacement factor for Displacement factor for BA, BC, CBCD? No. For what? For what this is displacement? Displacement factor is for C. Displacement factor for BA and CD. Are understood? Displacement factor is what? Or just observe it. Just observe it. How it is displaced. This displaced is like, this is displaced like this, na? Displaced like this. So you have to take what is the stiffness. So I understood this is, what is the stiffnesses? The stiffness and sum of the stiffness. What is the stiffness and sum of the stiffnesses? Just observe it. Just observe it. It's a PQ RS. So PQ means C, AB, DC, or if any other column is there, EF. So these are the individual stiffnesses divided by total stiffness. Not a giant B, giant C. Not. Are understood? These are the stiffnesses divided by total stiffnesses means AB, DC, EF. These are the individual stiffnesses divided by total stiffnesses. That is the displacement factor. Displacement factor for the column AB. Displacement factor for the column CD. Displacement factor for the column AF. That's the only. Not it's a giant of B. Are understood? Otherwise you can check what I write here. Okay, so go and check once again. So now you can see displacement factor. How can you write? For the column AB, what is the stiffness? Stiffness is 4EA by length is 3 meter. For the column AB, it's a CD. Stiffness is 4EA by 3. So something, that's why total is 80 by 3. Displacement distribution factor is say 1 by 2 distribution factor. Understood? So now a displacement factor. Now a displacement factor is minus 3 by 2 multiplied with distribution factor. What you will get? Minus 3 by 2 minus 1 by 2. 3 by 4. 3 by 4 is what? So exactly you can write 3 by 4. This is also 3 by 4. For the column AB, for the column CD, if any columns are there, if n number of columns are there, you have to write n number of columns. So how it is, why it is, what is the displacement, sir? See, I already said previously, see where it is. In a total shear of H1, it is distributed, it's taken some H1, it's take H2, it's take H3. Every column takes some portion. How much portion it's taken? By the stiffness of the column. By the stiffness of that column. Are understood? In the proportion of their stiffnesses. In the proportion of their stiffnesses. Are understood? So in the proportion of the stiffnesses of what? Stiffnesses of the columns. Stiffnesses of the columns. Are understood? Okay? So that you have to understand. Not a giant. No. If a giant stiffnesses, why we require? The rotational factors. For the rotational factors. Okay? So that's it. So now we displacement factors also we calculated. Displacement factors also calculated. Now we can do the problem. Now we can do the problem. For the problem also you have to write down this diagram. You can write like this, same thing. Sum of the fixed end moments. See, first you have to write down fixed end moments. What is the fixed end moments? Here is 0. It's that here is 0, here is minus 60. Excellent. See, minus 60, it's a plus 60. Here is 0, it's a 0. Okay, one thing I clear. I will write top side 0, 0. Here also 0, 0, 0. Okay, fixed end moments. Sum of the fixed end moments, you can write it inside minus 60. Here a plus 60. It's a, it's a B, it's a C, it's a D. Just take it's like as usual. And also rotational contributions. Rotational contribution. What is this rotational contribution for the BC? For the BC is 1 by 4, 0.25. It's a BA, 0.25. So minus 0.25, minus 0.25. Here also say minus 0.25, minus 0.25. Okay, that's the one thing. Now, what is the displacement factor for the AB column? Minus 3 by 4. 3 by 4 means minus 7.5. Where it is right? For the AB column, for the CD column, you have to write. For the AB column, it's a minus 0.75. For the BC column, for the BC column, you have to write down minus 0.75. How many columns are there? You have to write down the displacement factor. Displacement factor. Okay, one thing. Now we have to start the problem. Sir, how can you start? First see. First, as usual, joint B. First joint is joint B. As usual, you have to write what is joint B. Rotational contribution for the joint A, joint B towards A. What is that value? Rotational factor. Sum of the fixed end moments at the joint. Are understood? Sum of the rotational contribution at the joint plus are understood. Sum of the fixed end moments at the joint A, at the joint plus sum of the rotational contribution towards B from A to B, AB from CB, everything. That's it. Plus again. Are understood? Plus again. First thing, what you understand? First, what you understand? See, here translation also there. So this value are understood. Sum of the fixed end moments, sum of the rotational contributions for that joint towards that joint. Are understood? Towards that joint plus this value translational contributions at that joint. Translational contributions at that joint AB, AC, AD. Are understood? I will explain what is that value. Okay. So translational BA or BC, everything. Translational. That's it. Extra one thing is included. Okay. So see how we will solve. First thing you have to take care. First cycle. Take it as MBA. What is the sum of the MBA? Rotational contribution is minus 0.25. Sum of the fixed end moment is what? Minus 60. Sum of the rotational contributions towards that joint. From A is 0. From C? From A is 0. From C? At now we didn't calculate it. CB. So take as 0. And also translational contribution also. At now we didn't calculate it. So what is the translational contributions? BA and BC. The translationals. Sir, BC has no translational moment because the beam just straightly goes. The beam, it will go this. So exactly the beam, it goes to this. So BC, it will BC. There is no translational moments generated towards the beam. Towards the beam is goes to the direction. No, only the column AB is doing or moving right side, then only translational moment is generated. Okay, that's why the column BA is slightly tilting, then the translational moment is generated, not the BC is moving. Okay, so this value is MBA means BA and BC. For that BA we will get it. How we will get it? Next going. Okay, so at now we didn't calculate it, that is also taken 0. So what is that value? So 15 exactly, it's 15. So that's is exactly, this value is fixed previously as it is. So now MBC, same thing, minus 2.5, that's 15. Okay, 15. BA I write here, BC I write here. Okay, right here. Now goes to C. MCB, same 0.25. Sum of the fixed end moments is what? 60. Rotational contributions. See, rotational contributions from far end, from the D is 0. From the B already calculated. What is that value? 15, as usual previously, 15, and now the translational contributions CD, at now we didn't calculate it, just taken as 0, okay. So what is that value? 75 divided by 4, it's 18.75 minus 18.75. so as usual CD also you will get same thing, because factor is same, this doesn't change. Okay, same thing, minus 18.75 I write outside. Okay, some distance maintain. Okay, that's it. That's the only rotational contributions we calculated. But translational, now we can, the first cycle also translational. So translational, what is that value? M double dash, are understood? Translational, where it is, this value, this thing PQ PQ, are understood? PQ or QP, anything, both are equal. What is this value? Once again see, MPQ, what is that value? MPQ is displacement factor multiply with HR divided by 3, sum of the translational PQ, sum of the QP. That's it, na? That's it. Now you can see, now you can observe it. M double dash AB or BA, same. See, what is the displacement factor? We already know, 0.75. H into HR, what is that value? H into HR, what is that value? H multiply with height, what is that value? H is 50, height is 3 meters. 3 meters, huh? Height is 3 meters. That's it, 50. 150. This is 150. This is 3 meters, I think. 150. 150 divided by 3. 150 divided by 3, you can write it's a 50. We just taken at the 50. This is same. Now we can observe. Now we can observe 50 plus 15. So what is this, sir? What is this thing? What is these things? Rotational contribution. PQ and QP. It's a sum of the, not a one single thing, it's a sum means what? PQ, RS, TU, everything. It's a QP means everything, so that means QP, SP, SR, TU, everything. So what is this? what is this column, sir? For this, see, rotational contributions of AB, DC, if anything, EF, and plus rotational contributions of BA, CD, not CB, BC are understood for the only column AB, DC, and EF. That is the one sum, and another sum is BA, CD. These are the sum. Now we can observe it. M of AB. So this is a story moment divided by 3. Sum of the rotational contributions. Sum of the rotational contributions of that column from the top and the from bottom. So if it is taken as this is a from bottom, PQ na, this is from top. Sum of the bottom plus sum of the top. Now you can observe it. For the AB as what? AB rotational contribution is 0. So from the DC is 0. Okay. From the bottom, AB is 0, DC is 0. From the top, BA is what? BA is 15. BA is 15. CD is 18.75. These two. Not these 15, these 18.2. So both are equal. That's why you may confuse. I will clarify tomorrow another problem. If those two values are different, you may clarify. Okay. BA is 15. CD is 18.7. These two. Okay. These two. So see. 18. See, sorry. These two. One thing is 15. Another thing is 18.75. Those two. These two. This sum is also same. This sum is also fixed for any columns. For any column. For AB column. So what is this value? This value is minus 34.69. For AB column is over. For next CD column. Okay. For the CD column also just displacement factor is changed. The sum is fixed. You will get same thing. Okay. So for that I write here minus 34.69. Here also minus 34.69. That's it. This is the first iteration is over. So now goes to second iteration. Tell me, madam. 50 into 3, 150. 150 divided by 3, what is, madam? 50 is the story, shear 50, height 3 meters. 150 divided by 3, 50 anukunta. I think 50. It's 50 only. Okay. Go to second iteration. Again, MBA. See, minus 0.25. Minus 0.25. Sum of the fixed end moments. Minus 60 is okay. Rotational contribution from far ends. From A is 0. Again, from A is 0. From C now it's 18.75. Okay. From C now it's 18.75 plus this thing translational contribution. Are understood? Now it comes to the picture of the translational contribution. Translational calculation already calculated na? This are the sum of the translational contribution. BA, BC, everything. BA has 13.47. BC, there is no translational contribution for the BC. BC is just, there is no development. For the only AB, BA, translational movements are developed, not for the BC. Are understood? We already know it. Okay. Only AB, B position is shifting. That's why in the column of BA, at the joint of B, at the joint of A, translational movements are developed, not due to the shifting of the BC. Okay. So that's why the sum means what? BA, BC, B, something. Start with B. The sum of the translational moments. In this only we have BA. Okay. So if the two stories are there, you will get BA. If any sum of the top is there, you will get another. Okay, so another. So if the two stories are there, that's why they will use. Okay, BA, BC, and if any something BF is there, so you will get another two stories, three stories is there. Okay, now the translational moment you will get only for the BA. BA is what? 34.69. So that's it. From the A, rotational contribution is 0. From C, 18.75. Translational contribution is minus 34.69. From BA. From BC is 0. From BC is 0. But you don't write 0 because it's laughing. Because there is no translational movement developed because of BC. Okay, don't write any extra. Okay, so now what is this value? 1874, 1834, 60. Its value is 28.36. For the BC also same thing. You will get same thing because rotational factor is same. The sum is doesn't change. 28.36. Okay. So now goes to C. Now goes to the C. CB. Same, but it's a 60. From D is 0. From B 28.36. You already know. From B it's 28.6. For the same column, from the translational moment also it is CD and CB. From CB you didn't get any translational, you didn't get anything from the translational from CB. For the CD it's 34.69. You already know it. 34.69 we already calculated. What is this value? This value is minus 13.42. Minus CB is CD also you will get same thing. 13.42. Okay, so that's it. Minus 13.42, 13.42. Okay, 13.4 to 13.4. Once you calculated the rotational, now goes to again translational. Again translational. MEAB. MEAB. What is that? Displacement factor multiply with story moment. 50. Story moment is what? 150. Story moment is 150 divided by 3 is 50 plus rotational rotational contributions from the top, from the bottom. From the top you will get 28.36, 13.42. From the top, from the bottom 0 0. Okay, from the bottom 0 0. If it is also a hinge you will get lot of values. Okay, so now you will goes to 28.36. next one is same thing, these values 28 point. So B, so that's BA, and you will get CD, these two things. Minus 13.42. Minus 13.42. What you will get? You will get it's a minus 48.7. Okay, something same thing. AB also you will get, CD also you will get same thing because the rotation factors, displacement factors are same. Minus 48.7. Minus 48.7. So again goes to the translation, again goes to the rotational. Okay, again third iteration, that's the second iteration is over. Third iteration same BA 0.25. sum of the fixed end moments minus 60. So rotational contribution from the far ends it's a 13.42. okay, minus 13.42, and translational contribution is minus 48.7. what you will get? You will get 30.53. MBC also you will get 30.53. so M1 dash CB you will get plus 60. from BC you will get 30.53. and translational you will get 48.7. what is that value you will get? You will get 10.46. already we got 13.4. Okay, you will get 10.46. 10.46. MCD also you will get 10.46. Now rotational. Translation of UAB you will get same 0.75, 50, 30.53, 30.53. Okay, so it's here, it's the 10.46. 10.46 from the top, from bottom is 0, so this value goes to minus 52.55. so yeah, same thing, M of AB, CD also you will get minus 52.55. so goes to fourth iteration. Do it. I will write the values. Okay, I will write the values. 28.33, it's 30.53, 30.53 here, minus 10.46, minus 10.46. Translational, it's a 52.55, it's a 52.55. Third iteration. Fourth iteration, if you do the fourth iteration you will get 30.75, 30.75 here, minus 9.55, minus 9.55 here, you will get minus 53.4, minus 53.4. 4 is sufficient, no need. If you want more energy, do it, otherwise leave it. Once you got these values, what is the final end moment? That's the question. That's the now question. So final end moment is what? Final end moment is what? You already know what is the final end moment. First I will write. So what is the final end moment? MAB is a fixed sum of so fixed end moment at the place, rotational contribution at the joint towards other joints, rotational contribution of at its own end multiply with 2, rotational contribution from the far end plus a translational moment generated at the joint. Okay, so that is based on that. Now we can write for the fixed end moment is 0. I will write fixed end moment is 0. Rotational contribution is also 0. Rotational contribution from the far end is 30.75. That's it, na? From the far end is 30.75. And the translational moment is 53.4. What is that value? That value is minus 22.65. That is MAB. MBA also take it. Just think, I will write MBA is its fixed end moment is 0. Its own rotational contribution is 30.75 multiply with 2. Far end for the BA, far end is A. From A is 0. From the translation is 53.4. What you will get? It is 8.1. MBA. MBC, now you can see it's a 60 fixed end moments. Rotational contribution is 30.752. From the far end contribution is this value. This value comes to this place. Far end contribution is 9.55. Translational, there is no translational because BC is just there is no moment generated due to translational. Translational generated in only the column BA and AB, CD and DC, not due to the moment of BC. Okay, there is no translational moments generated in the BC beam, only generated in the column. Okay, so the translational is 0. What is that value? Minus 8.05. That is MBC. MCB. MCB. So 60, its own is this value from far end plus 30.75. Translational 0. What is that value? 71.65. Here also you will get same thing. 71 is plus, it's here 71 minus you will get. See, fixed end moment is 0. Own it's 2. Own it's 2. Okay, so from the far end, from the D is 0. Translational is minus 53.4. 53 and 20, 74, something 71. You will get it minus 71.65. This is MCB. This is MCD. MDC, you will get fixed end moment is 0, its own contribution is 0, from foreign contribution is minus 9.55. Okay, translational 53.4. What is that value? That value is minus 62.95. This is MTC. That's it. Once you got the total fixed end moments, you can draw shear force, bending moment diagram, anything. A very simple diagram. Okay, very simple. If you got fixed end moments, you can draw now bending moment diagram, shear force, anything. That's it now. That's the problem. That's when you have a sway, you have to do like this. First problem, you can feel some clumsy, what is the value. But once you have to understand, this is also same routine process. Just add those values and do. The iterations are very simple. You don't feel it's complete. It's very simple. Very, very simple. Once you are stepping, you can feel it's good. Once you are up to where you sit in outside of the lake, you feel the swimming is difficult. Once you drown into the water, you feel that's good. You can feel it is better, and also it is easy. Okay, it's very simple. First problem, that's why I took every value what is I say it is. For the next problem I can't say, I directly take that values. Okay, so if anyone has any problem, ask me doubts, otherwise leave. Tomorrow I will solve another problems, and I will explain if the story height is different, what we have to do. Explain tomorrow. I will solve another problem also. I will solve another problem in this sway analysis, and I will discuss the story height is change, what we have to do. Okay, but the next classes I have to do complete this topic, Kani's method. That's it.